of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV experiment as nights. You realise that you do not have to be a radio amateur or need any ATV equipment to participate anywhere in the world. Also participate on the night by coming up to the Queen's Domain club rooms. Yes, right on top of the Queen's Domain in the heritage-listed Coast Wireless Station. You never know, we might get you in front of the camera or behind doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30 p.m. local time. We'll see you soon. This is VK7OTC.
It occurred to me not too long ago that
it's supposed to be summer. Would somebody tell them?
Somebody tell somebody that
it's summer and the climate change.
It's a Microsoft summer.
They're telling us that it's all heating up. The most hottest decade that's ever been recorded.
Okay, this is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania with our ATV Experimenters Night. And I've got our regular guest, Rex, VK7MO, in the studio. Welcome, Rex.
Thank you, Justin.
How you doing?
I'm alive, mate. That's pretty good.
Vertical and above ground. Love it.
Okay. What I thought would be interesting tonight is to talk about the first VKZL QSO on 3.4 gigs, which was done between VK4UH and ZL1TPH just prior to the field day about 2 weeks ago.
Cool.
Unfortunately, by the time the field day started, conditions faded, so they didn't get any points for the field day, but they did get a really notable contact.
Okay.
And I've been spending a fair bit of time with them. Oh,
yeah.
Yes.
Keep talking.
Analysing this contact.
Okay.
So we'll just go on to the Hepburn chart, which looks a little bit odd, but if you just squint a little bit, you can see there's, that's right, a nice bright patch all the way from Brisbane to the north of New Zealand.
Where that line is.
Where that line is. And the distance was just over 2,000 kilometres.
2,197
kilometres, yes.
Very impressive.
Now this was the mean sea level chart. You can see a nice big high there in the Tasman, and it's the high sort of circulates to both ends of the path.
Yep, that's 1,022 hectopascals.
That's right.
Cool.
Now, this Kevin VK4UH, he rented. I don't know how you can do this for a field day. It doesn't seem like the field day rules to me, but he rented this house on the top of a mountain for the field day.
Okay.
And this was the setup. Now, this mountain is called Mount Mobolan,
Okay.
as if I'm pronouncing it right, and it's over. The mountain itself's over 1,100 metres,
Right.
and you can see in the background a couple of TV towers. So
Okay.
I don't think it services Brisbane, but at 1,100 metres it would service
A fair bit.
a fair bit.
How far in from the coast are we talking?
About 200 kilometres.
Oh, okay, so fair way.
Yes.
Yeah, okay, okay.
Now they obviously took a fair bit of gear with them.
Oh,
If you look at
yeah.
all the antennas and dishes, and
Yeah.
there's a couple of dishes on the balcony which you can't see very clearly, and
And a couple of quite decent Yagis
Yagis
sitting there.
and so forth. Next slide. This is what ZL1TPH was running.
A tow bar mount.
Yes. Now,
I tell you what, that's pretty pointed pretty low too. That's sort of...
you shall see in the next slide why it doesn't matter. But,
Oh, okay, okay.
But I'm not sure whether he has to drive the car to rotate the dish.
Okay, okay.
And then you can see the PA and the low noise amp stuck
It's
on the
actually mounted on the dish. That's
on the
pretty
dish
impressive.
to keep the feed levels as low as something.
Yeah.
So, and next slide. Now that's his.
Okay.
That's his takeoff from that site. Right on the horizon, you can sort of see water.
That's not snow. That's
no,
sand. Sand. I assume. Yeah.
That's
Okay.
sand.
Okay.
But right on the horizon, you can see water. So
Yeah,
it's,
okay.
it is an excellent takeoff.
And it actually dips out. So
Yes.
that's.
He's only up 108 metres, but
Yeah.
you
You've
know.
got a perfect view to
perfect view to VK.
west.
Yes.
West.
Yes.
Okay.
Now, this was what I was interested in doing. These are, what I did is I got hold of the radiosonde trace data from both Brisbane and a place called Wenapulai, which turns out to be just a suburb of Auckland,
Oh, okay. Okay.
which are the closest
Yep.
for both sites. And the day before, the little dotted vertical line is what is necessary to get a duct to work around the curvature of the Earth.
Okay. So anything that goes past that line.
More negative.
Yeah.
that can theoretically work.
Okay.
In practice, you usually need something a lot stronger than that.
Okay.
I'm not exactly clear why it must be a lot stronger, but one obvious reason is that you're only measuring this data at each end, and you really want it all the way.
Yeah.
So you want a situation where at least both ends are well
Yeah.
past
Okay.
to have a chance that
At the same height, I assume.
well, you would like them at the same height, but we will find out as we go through that was not the case.
That's interesting.
Yes.
So at the New Zealand end, it was at a 1,000,
Well,
just
well,
below.
perhaps, but it's worth now moving to the
Oh,
next
okay.
day. This
Cool.
is the day of the actual contact.
Okay.
Now you can see where the duct went off the scale.
Wow.
Now it only needs at minus 157 to get round the curvature of Earth, and this is minus over 1,000.
Wow. Okay.
Now, I have never seen a duct that strong. All the ducts I've looked at and, and so forth. Now, this is the first bit of interesting information.
Okay.
That duct was at 922 metres in New Zealand, but it was at 1690 metres in Brisbane.
Didn't follow the curvature of the Earth.
Well, maybe the duct itself was sloping.
Yeah. Okay. Wow.
Now, that's different to what Andrew Martin says in all his papers he's done on ducting.
it's the same height.
Yes.
It's the same height. I remember that talk.
Yes. So that in itself is a bit of interesting information. At the Brisbane end, it wasn't so strong, but minus 456 is still strong.
Well and truly.
Uh,
Can Can I just go back to the Hepburn chart?
Yes.
Because I want to see what the Hepburn chart actually looks like. Because at the New Zealand end, it is extreme. Like it's bordering on. Oh no, not quite, because that's extreme.
That's extreme, but it's much higher than it was.
And it's certainly higher than Brisbane, because that's the Brisbane end's green.
Yes.
And the New Zealand end is brown, dark brown.
And I should explain that the measured duct is at Auckland, which is down here
Which is much stronger.
which is much stronger than actually where he was.
Yeah. Okay. All right. Okay.
But
cool.
which sort of explains why we've got this massive duct at Auckland
Yeah.
near the New Zealand end,
Yeah.
and still a good duct
Well and truly.
at Brisbane.
Okay. Next.
Okay, next. Now this is the day after, and essentially those ducts have disappeared.
Yes.
There's a little duct
Lower down in New Zealand, and higher up.
Well, I would say that's a different duct altogether because
Okay.
it's much higher.
It's a different
You
day
know,
and different.
different. So it was only there for one day, but the Radisson data really gives you a nice clue as to what was going on.
Well, truly. Okay.
Now, if this is just the 3 days.
Oh, okay.
All on one screen, so that you can see what actually happened over those 3 days.
That's a huge difference.
Isn't it? It's dramatic, isn't it?
That's just.
Did they try a higher frequency? Did they
Wow.
try like 10?
No. Thank goodness. They might have done it.
Because when Hayden and I worked those guys in VK3, we were astounded at 3.4 even seemed stronger than 2.4.
Yeah.
And like, when Ralph said, "Oh, have you guys got 10 gigs?" and we went, "No, didn't have it with you," because it probably wouldn't work anyway. I said, "That's 60 watts." Ooh, he goes, "It might have been worth a crack."
Well and truly. Well and truly.
Yes. Okay.
It's outrageous. Okay.
Next slide.
Yep.
Now, the next thing I looked at was the absorption. When you get to 10 gigs, absorption starts to... 24 gigs absorption actually kills you.
Yeah. Okay.
Along past the 10 gigs, you can get 40 dB of absorption loss.
Whoa.
But you can use the Radisson data and feed it into ITU formulas
Yep. Okay.
to work out what the absorption is.
Okay.
And at 3.4 gigs, it's still significant. That was about 11.7 dB. Unfortunately, the ITU only gives you a formula that works from 1 gig upwards.
Right.
So there's a sort of an assumption that absorption is not even important below 1 gig.
Yeah. Yeah.
But below 1 gig, of course, we come right down to 432 and then 144.
Yep.
So all I can do is assume that the absorption's 0 at
Below 1.
1. Okay, next slide. Now, this is something you won't be able to read, but what I've done is I've produced a spreadsheet where I feed in all the information about the system, such as the power input, the antenna gain,
Okay.
the feed line losses, the absorption, the
Noise.
noise in the receiver, the external noise.
Ooh, all the different types of noise.
That's right. I mean, if you've got a feed line, that actually produces not only attenuation but noise.
As you've told me many times.
Right. Oh, you wrote this lesson. The biggest difficulty is to measure the external noise at particularly 2 meters, because
Okay.
if you're anywhere near a city, you get stacks of noise.
And the ITU figures reflect that. It's because there's a suburban figures versus
Yes.
the
Well,
rural figures.
there's actually 3 levels of important figures. The ITU give you at 2 meters what they call the galactic noise.
Yeah.
Okay.
And then when you get up higher in frequency, the dominant noise is the actual noise from the atmosphere.
Yeah. Okay.
So you've got to make some judgments, but you can put reasonable figures in.
Yep. Okay.
And that then allows you to compare what the system performance would be if there was no frequency dependence in the duct.
Okay. Okay.
Now, there's a lot of discussion in the amateur literature that the reason it is so much more difficult to work ducts at microwaves is that the ducts are frequency sensitive.
Right. Okay.
None of the professional literature agrees with this.
Oh. Okay.
Uh,
So they're just basically saying that it's frequency independent.
That's right.
If you have a duct, it can be any frequency.
The professional literature, in this case the ITU, tells you that at the low frequency end there's a cut-off,
Yes.
and that cut-off is dependent on the thickness of the duct and the intensity of the duct.
Okay. Okay.
But that once you get to a frequency where it works, it should just keep working.
Okay.
And that sort of comes from just sort of geometric optics. Once because the radio refractive index essentially doesn't change.
Yeah. Okay. Okay.
So whatever, and it's a refractive process.
It's
Yeah.
bouncing along in the duct.
Yeah.
Yeah. Okay.
Now, because the amateurs came up with the view that it's much, much harder to work a duct at higher frequencies, which is contrary to what Richard just told us, that
Well,
3.4 was easier than 2.4.
Yeah.
VK3KOQ, who did this sort of work professionally for the PMG to design the microwave links over to Western Australia,
Yep.
came to the view that the duct entry angle had to be much closer when you're on a higher frequency.
What do you mean by closer?
Nearer to zero.
Okay.
Essentially,
You have
he's
to-
really saying if you go very high in frequency, you've actually got to be almost in the duct.
You go. Yeah. Which is actually an advantage in Tasmania. Yes. Potentially. Because we can get on top of mountains which are somewhere in the vicinity
Sometimes
of the
like
duct.
Mount Wellington or often higher than
Yeah,
that.
except the good ducts are usually about 600 metres round here.
Which means we cut them off.
We go above the duct
Yeah.
and our signal doesn't get down to the other end.
Correct.
So it's sort of,
Yeah.
but there are high level ducts, and Hayden and I have been using them, and I guess you guys used it
Well,
because, for your contact.
Yeah, that's right.
That radioson data, that was meters, wasn't it? So that was 1,000, just under 1,000 meters and above 1,000 meters.
That's right.
So
Yes,
yeah.
but the strong ducts that get us across to Western Australia are all around 600 metres.
Okay.
But occasionally, I mean, if you're working a duct in southern Tasmania to Victoria, it's got to be high because we're going to go over these bloody mountains in, this,
In the middle.
in the middle.
Over the Central Plateau, yeah.
Yeah.
But taking that point, the 10 gig record that you set to Western Australia, you're at sea level, and that duct was at 600 or
About 400. Yeah.
400 meters. That entry into the duct is nowhere near zero.
You're absolutely right, and we will go on to that.
Yeah, I'm sorry.
That's all right.
Okay.
That's all right.
So next slide.
No,
No?
I just want to go into this a little bit more. Unfortunately, it's not obvious, but the what I do calculate, which for those who can see a screen that's readable,
Yep.
over to the right, where it comes out green up there, but it's actually red.
It's actually red.
Is it?
Yeah, sorry
Yes.
about that.
I'm comparing the system performance between 144, which they also did contacts,
Okay.
and 3.4.
Yep.
And you will notice, if you look carefully, that there was 3.4 system performance was down by, I think, one case 15 dB, is it?
13, minus 13.1.
Minus 13 and minus
17.8.
17. Now, the reason there's a difference is on 144, the Brisbane group were running 350 watts.
Okay.
And the new ZLs were only running a 9700 with sort of 100 watts. And and I've got different feed line losses and things in the calculations.
Okay.
But the interesting thing is that's saying that 3.4 should have been weaker by somewhere between 13 and 17 dB. Now, unfortunately, amateurs don't measure signal reports accurately. They say things like 5 and 9 and 5 and 5, and they could be the same. But
although hopefully that I'll just say this. Hopefully that changes with SDR receivers, because SDR receivers not only give you the S meter, they do actually give you the reading, the actual dB of the reading.
Okay.
In the display. So you can actually read off what it is, minus 104 dB or whatever it is.
Yeah. I mean, you can, with digital modes, get better readings, although unfortunately most of them are not linear. Particularly QRA flattens off at about minus 14 dB, and JT65 flattens off at about minus 10.
Right. Okay.
But one way of doing it is just send a signal tone, and then when you've got time and you come home, you feed it into Spectrum Lab, and you can measure the signal to noise ratio quite accurately with Spectrum Lab. But essentially the interesting thing is that 3.4 gigs was even stronger if you take account of the lower system performance.
Yep.
The 3.4 gig signal that Kevin reported was averaging about 5 and 5, which was somewhat stronger than he was getting on average about the same time on 144.
There you go.
Exactly right. Yeah.
And ZL1TPH reported about the same.
Yeah. Okay.
Now that's probably because there was 350 watts on 144 against 100, which would have made sense. So not only when you properly take system performance into account is the higher frequency not tailing off, it's actually better.
Increasing, yeah.
Now, one explanation for that is that there is a lower frequency cutoff to the duct.
Yeah, okay.
So we'll go to the next slide. I think I've got these slides out of order, but that doesn't matter.
We need to keep going?
No, what we'll do is we'll just go through this.
Okay.
The VK3KOQ, essentially his analysis comes to the conclusion that if you need, say, a duct entry at, say, 2 meters of 1 degree, and you go up to 1296, you need 0.1 of a degree.
Right.
And you go up to 10 gigs, you need 0.01 of a degree, which means you've just got to be in the duct.
Yeah, okay.
Now there's a I mean, obviously, if you beam further out, you can beam at a lower angle.
Yes.
And that can solve the problem. The problem is there's a limit to that, because the Earth's curvature starts to slope the duct around, and that means for any distance you are below a duct, there is an optimum distance out where you get the lowest angle.
Yeah. Yep.
And all I've done is, with a spreadsheet, worked out what that optimum angle is for distance below the duct, and it's sort of that green highlighted stuff.
Yep.
And you'll notice that by the time you get down to about 500 meters below the duct, even the optimum angle is still 1 degree.
Okay.
So on that basis, and taking account of VK3KAQ's paper, it would be very unlikely that you would ever get a contact with 1 degree of entry angle at 10 gigs. But that's about what my contacts across the Western Australia were.
Yeah. Okay.
So some of this, I think there's still a bit to be learnt. And even 4UH was 590 metres below the duct, which sort of puts you into the 1 degree area. And ZL1TPH, he was 800 metres to the duct, which is putting you much more than 1 degree. Now, when I looked at the professional literature, the Americans actually put me onto a brilliant little paper by the US Naval Research Laboratory,
Unclassified
in 1974.
Okay.
And what they were trying to find out, they were trying to learn about ducts, because back in 1974, the only way you could find out if the enemy was on the horizon, and you were still trying to remember Pearl Harbor,
Okay.
if the aircraft was invisible because there was duct in the way,
Okay, I'm getting it.
then it might be quite important.
Well, I'm sure.
And there's a ship in the harbour at Pearl Harbor too.
Correct.
So the Americans put a lot of effort into this, and they concluded that you can do what is, for those who remember their high school mathematics, a simple formula, which is the ratio of the two refractive indexes. Now, the reality is the refractive indexes of air between the surface of a duct and below it are very little difference. They're things like 1.004 and 1.005.
Okay.
And by the time you take the ratio 1.004 and 1.005, it turns out to be 1. And while it's not immediately obvious to me, because I've forgotten my high school mathematics, that when you take the R sign of small angles, they come out. So if that comes out to 1, this is the critical angle, comes out to 1. And so the Americans say, for all practical considerations, the ratio is 1, therefore the critical acceptance angle is 1 degree. And so this is quite different to what Andrew's statement is, and quite important, because it does mean that I could have a contact when I work Western Australia at 1 degree. It means that we're starting to get very close to the limit here, but it doesn't quite add up, because the ZL contact was 800 metres below the duct, which is getting up about 1.2 degrees or something like that.
Well, we're 800, so 1,000 is 1.6. So
well, the optimum would be sort of going this way. So
okay. So
you could beam you could beam further out.
And enter it further out
at sort of 1.12 or something.
Okay.
It's like at 800 metres, you're going to be somewhere between here and here. So 1.2, 1.3. So there's more to it than even the Americans in 1974 said. Now, I can imagine, for instance, and this actually comes from Andrew's acoustic sounding stuff, the ducts are not flat.
And remember that in the paper.
Yes.
And he was talking about ripples and all
ripples.
sorts of... Yeah,
That's
yeah.
right. So it's possible that this ripple just changes the angle of the duct enough to have allowed these contacts to happen.
Well and truly. Well and truly.
Now, on the right of this, we have a graph that comes from the ITU.
So the next...
The next slide.
Yep.
Which works out the minimum. Now the ITU, well, they reckon there's no maximum. There is a minimum.
Okay.
And they reckon the minimum is different for elevated ducts than for surface ducts. Now we're only interested in elevated ducts.
Okay.
And what this essentially says is, if you've got a very strong duct, and they only plotted up to minus 600 for the size of the ducts, and of course we had 1,000 at one end.
Well and truly.
You know, then it can be a very thin layer, and
It's getting down to 10 metres, so...
less
than 10 metres, sorry.
Yes.
So this is at 10 gigs.
Well, unfortunately, the scale is not very helpful at VHF because that's 5 gigs and that's 0.
Yeah, okay.
But what that's really saying, if you're sort of down below VHF, that you need a 600 on the intensity.
Strong duct.
A strong duct, and it's got to be at least 10 metres thick.
Yeah, okay.
So, one of the reasons why 3.4 might have been stronger than 2 metres was the duct wasn't really thick enough to transport 2 metres.
2 metres.
2 metres.
Because that's down here, like that's somewhere in here. It's just above that line.
That's right. Yes. Now we've got the problem that we had a different duct intensity at both ends.
Yeah.
So next slide. What I did is I looked at the radio sun data and got the parameters of the duct.
Okay.
And at the New Zealand end,
Ooh, yeah.
the duct was quite wide, but if I took the whole width of that duct, it was only minus 211, whereas the peak of the duct was 1,000, but that was only a dot point, so it's a bit hard to say how how thick that was.
Yep.
But the dots either side of that, there was a duct 18 metres thick and minus 600, which is still a very strong duct.
Yep. And getting down into that chart sort of...
That's right.
Size.
The implication is that should work.
Yeah, okay.
At the VK end, I was down to minus 194,
Yep.
but it was over 40 metres, which was still reasonable.
Okay.
So we then have a look at the next slide, and what I tried to plot, because unfortunately, like the 100 metres ducts, so I'm guessing, and what I think this shows is that 2 metres really at the Australian end, which was the 40 metres and 194, the duct really wasn't getting down to 2 metres, because you think that's 5 gigs between there and there, so that's about 1 gig.
It's just above the line.
Yeah, so it's highly likely that the 2 metre duct wasn't working properly.
Yeah.
Now, it'd be nice to have a graph like this that was expanded up,
But yeah, this goes to the ITU was saying that the cut-off's at a gig, so you're not going to find any ITU charts below a gig.
Yes. Okay.
Yeah. Okay.
Cool. Next slide. Oh, that's what I regard as the next challenge.
Cool.
Now, I'm not saying that any of what I've discussed has a degree of definiteness about it, but I think there's a whole lot of interesting things that if we gather data every time we do this stuff,
Correct. And add to the picture.
So every time anyone goes out and does ducting, record everything. And now the best way of recording signal strength is do it on digital, say QRA64.
Yep.
Just send a single tone for a period, and then we can process those single tones in Spectrum Lab.
Yep.
And measure the signal strength quite accurately to overcome the sort of problems that.
Estimator reading.
Well, it's
5 and 9.
well. The trouble is, if people are comparing an S-meter reading at 144 on their 9700, and then they put a bloody transverter in front of it.
Meaningless.
Meaningless. Yes. So. Probably a by ear S-meter is even better than the reading off the meter.
Correct.
And by ear readings, I reckon some people will give you 5 and 5, and some will give you 5 and 8, and it's exactly the same.
Correct. Correct. The by ear is even worse, I think, than probably the calibration on this S-meter. But anyway.
Well, not when the S-meter's sticking behind a transverter.
Correct.
With a whole lot of gain.
You've got a whole lot between A and B.
So what I am recommending is that anybody that goes out looking for ducks,
Yep.
please do at least a few single tone tests.
Yep.
Just record the files.
Yep.
And then send me all the data, like the power and the dish gain and
Yep.
any feed line losses, so we can build up these pictures.
A library of these contacts.
And try and tell me the dates, and then if we've got radios on data, we will use that to analyse things like absorption and the height of the ducts.
Cool.
And that's it.
That's fantastic, Rex.
Thank you.
Thank you very much for our impromptu ATV night. I think we did pretty well because we're it's 8:08. So there you go.
we took 45 minutes. 40 minutes.
40 minutes. So that's very good. What's that? Okay. Well, are you going to show us?
Well,
Come on. You change seats.
Alan is coming in.
I'm scared of cameras. And that hurts your fingers.
Yeah, it does.
that's a very small suitcase.
It's a very small suitcase.
Thank you.
Oh,
Leo Bodnar. So this is your GPS.
this is my little Leo Bodnar
Okay.
GPS and clock, frequency, source.
Hang on. We need this on close-up camera. So let's zoom in the right way here. And okay.
And for size, you can
Oh.
put that's a business card.
So let's zoom to that. So you can both see. That's a business card size. In fact, there's a business card underneath there, which is doing some gratuitous advertising.
Yep. So it's very small.
Well and truly.
It comes with its own GPS antenna,
Oh, cool. So active antenna.
active antenna.
So a little active antenna that goes with it.
And what does it do? Well, it tells you on the thing what it does. It's out of focus.
I can.
Or is that my eyes?
Oh well,
Focus.
it's out of focus. In fact, it's
It's a resolution issue.
on that screen.
Oh.
On that screen, what it actually says is mini GPS reference clock, 400 hertz to 810 hertz, 400 hertz to 810 megahertz.
Yes. You connect it to a PC and run a very small .exe file, which I can't do on my phone, but I can
So it's a very stable DDS.
Yes.
Right.
Cool.
What's happened here? Why is this looking so strange? I can't work phones. It's technology.
What are you doing with a fancy GPS then?
So we're back over here.
Right.
Oh, okay.
If you
Hang on.
can-
Yes.
Trying
I'll
to
hand
touch
back,
the screen.
I'll hand back these two things to you.
That's a little bit of the software before it goes black. Yeah, a little bit of the software that runs. You can see my desktop's very cluttered. It tells you that there's quite a lot of satellites in sight. That was
Which is this
inside,
Hang on.
and you.
Which
Yes,
is this bit.
and also just up above that is a window where you set the frequency you want between 400 Hertz and 810 megahertz.
Cool.
And it outputs a frequency that is locked to the GPS. Now, if you swipe that just sideways, the wrong way.
I hope you have
there
a-
you are.
Oh, there you go.
And that's on my frequency counter at 10 megs. It's itself GPS locked
That's
separately to this one, so they're not talking
okay.
from one source, so they're both separately locked. And that's showing 10 megs to 1/100th of a hertz, I believe. No,
Yes.
to a tenth of a hertz.
10th of hertz.
Yeah,
Because it's 10th. There's 2 zeros after
two
the decimal.
zeros.
But they're both locked on the same lot of satellites.
Not necessarily. Yes, they could be locked on, but there's a whole heap of satellites up there, and yeah.
Just come forward, Warren, and we'll let Ron in as well, so he can see what's going on.
There's a
We're all looking at the screen up here.
There's
So
a lot of
that-
zeros.
So I got that a couple of days ago, and that's going to go black in a second. Oh, very good.
No.
So yes, and you can dial in 49152 megahertz,
Well-
49.152.
Yep.
Which probably means a lot to people with IC-9700s,
Yeah. No. Okay.
because that's the reference frequency in an IC-9700.
Is there any limitation to what you can set it to?
Yes, there is.
Okay.
If you look down the right-hand side of that, the laptop screen,
So this bit.
that gives you the reference frequency it's using and various multipliers and dividers that it
Okay.
uses to get to whatever. If you put in a frequency it can't do, it will say can't do.
Yeah.
And
okay.
the nearest frequency I tried to put in 10 meg and 3 hertz or something like that, and it said can't do. The nearest we can do is 10 meg 3.0159978. And yes, there's about 6 decimal places.
Yeah. Okay.
Yeah.
Okay.
So it tells you, and is this good enough? If yes, load it. If not, try again.
So what sort of dBs is this thing worth?
€99. No, 99 Great British Pound.
Oh, okay, so about 150.
Yeah.
Okay.
You wait until they exit.
You can get another one.
Sorry.
Oh, by the way, I only ordered it last week sometime.
You kidding me?
No.
Because the stuff from the UK, I find it takes forever.
It came FedEx.
Oh, okay.
Yeah, FedEx from the UK is pretty
Yeah,
quick.
Yeah.
Okay.
It was, whichever day it arrived at 11, no, was it 11 a.m? I was going out, and I checked at 9 o'clock it was in Sydney.
Flippin' heck.
It was scanned in Sydney, and then it appeared on my door several hours later. There
it's-
is another one
Okay.
that has 2 outputs, but
Out of
So-
phase or?
you can have the same frequency with 90 degrees phase shift, or any other phase shift for that matter.
Okay.
Or you can have them as 2 different frequencies, however they have to be related.
Multipliers of each other or something.
Yeah, multiplies, divide.
okay.
You can't just pick 2 random frequencies and assume you're going to get it. Like you can't have a 10 meg output and a 49152,
Yeah, okay.
which would be very good for the icon.
That's pretty impressive.
It's not bad.
That is very impressive, in fact.
And as I said, little aerial whole heap of satellites inside the house.
So when you switch it on, I noticed there's a little LED on one end.
It scared me for a while because it came up red. I thought it had come up red to say it had power, and then it'd go green when it locked, but it stays red and it flashes when you change frequency before the loop locks.
Okay.
So, yeah.
So is it powered via the USB?
Powered by a USB.
There's a USB.
It doesn't need to connect to the computer. If you just put power into that now, it'll give out 10 megs.
Or whatever you last set it
Whatever
to.
you last set it to. Yeah.
That's very nicely made too. That's very impressive, Alan.
Yes. I haven't got a 9700 yet, possibly. I'm working that way.
So you're working on all the
niceties. I can use this into the transverter to lock the transverter.
I can see this getting to a point where you've got so many accessories, you just have to buy the 9700. I see which way you're going.
Yeah, well, this one will get Richard and Rex a little more excited.
And what's that?
I'm not sure. There's some sort of matching on it.
Yeah.
There's 40. Okay, well that gives you a hint. It's 49.152 in, and
that little coax connector there is also 49.152 in. You get a choice. You can use that one or that.
Oh, this and I now notice that there is an ICOM IC-7900 injection board.
Yes. So that is the.
So that sits into the
oscillator area.
Okay.
You feed it with signal from this
we
other little box, and it overwhelms the oscillator and hopefully locks it to 49.152.
We can't see that. Yes, now we can. So I'll turn that round so people can read.
The bit I find amazing on that is that little
IPC.
That little coax connector.
Yes, that little coax connector
which is about a millimetre square.
Oh. Field of view here. It's an MMX connector?
No, I think it's smaller than MMX.
Oh, okay, righto. And if I turn it over, there's the little...
You'll notice there are 3... And I assume they're resistors or open circuits, and there's an inductance sitting on top. Hello, look, there's people running in.
Got a 9700 though.
No, he hasn't got one
No,
yet.
I didn't think so.
But he's getting he's getting all the accessories though, Hayden. He'll just get to a point where he'll go, I've got to buy this.
Well, I wanted this other thing, and I thought I might as well get this at the same time.
That's how it happens.
Yeah.
So does this come from Leo Bodnar?
Yeah.
This is...
It's got his name on it.
Yeah.
Oh, it's... no, of course it has.
Yeah.
Leo Bodnar Electronics. And so this is...
Terribly pricey for what it is, I guess, but...
So these...
one of the best things about it, so it uses mounting screws that already exist, so those bosses... sit it where it should go, but down the right hand end, see those 2 spare holes?
Oh yeah.
See those 2 little holes there? He provides you with slightly longer screws to make up for the board mounting bosses, and those 2 holes take the original screws, so you store them in situ in case you take it out and you need those screws back.
Nice. Very nice.
I am not associated in any way with the manufacturer. I am merely presenting.
Very well thought through, though.
Correct.
And he did it very quickly, and he got it to market, and he said, yeah, I've got a batch and I'll send them out as I get them. And as I said, 4 days, roughly. 4 working days.
From where?
England.
That as well.
You go.
The whole lot.
Did you get hit with that import duty?
No. Quick, and that'll...
There must be a price range under which you don't get hit with import duty. Because we
Or-
bought something from England that was
or
about
it comes
$300 worth, and we got hit another $100 in import duties.
Was it a letterbox?
Yeah.
Very impressive letterbox too.
Yeah, but very expensive in the end.
A letterbox.
A letterbox.
I saw it.
From
You
England.
put it on
Yeah.
You put it
It looks
on
pretty cool.
Facebook.
So,
It's very swish.
yes,
Very impressive.
yes, I like playing with things, so that was my excuse for it.
I love it. I love it. So who else has got something? Because this night's turned into a pretty reasonable ATV night. It's just,
Now-
and it wasn't going to be an ATV night at all.
Now the catch is to
noticed
get
that-
everything back in.
One question about the GPS was,
Yeah.
you said your output frequency will be whatever you last set it to.
Yeah.
So if you fired it up and you say you had it set to 10 megs, it'll come back with 10 megs, even without the antenna attached?
No.
Yeah.
I'm not sure. I suspect.
No, it will, but it won't be
Yes,
stable.
it won't be stable.
Yeah,
It
yeah.
may be somewhere in that region.
Yeah.
Yeah.
Maybe. I haven't
Okay.
tried that.
I suspect it's probably pretty close, and if you left that on for a little while, it would probably stabilise. But yeah.
I'm suspecting it's got a chip in it similar to the one in Silicon Chip where they had their GPS reference some time back
Okay.
that had 3 or 4 outputs.
Right.
And this one's got 1 there. His other one's got 2, and you can get a chip that you can set 3 or 4 outputs, I forget.
Okay.
But I think they all have. You set 1, and then the others will be subsets of that frequency,
Okay.
given various multipliers and dividers.
Outrageous.
Yeah. But yeah, I just like that one with all the zeros.
Very impressive. Very
I'll
impressive.
put it on the 1,000-second sample and
Go and make a cup
get
of tea.
another digit. 1,000 seconds is 18 minutes, isn't it? Somewhere about there.
About that, but you need to do that twice or
Yeah.
3 or 4 times. So give it an hour.
I'll have to wait till the boss isn't at home to ask me what I'm doing and why I'm not doing
Well, I see
the
you-
other important things.
On your,
Oh, you have that problem too.
on your photo there, you were occupying the family dinner table there.
Yes, that was the
I
family
wouldn't-
dinner table.
I wouldn't get away with that easily, not for a longer period of time anyways.
Ditto.
I will possibly be able to for the next 6 weeks come next
Oh.
Wednesday,
You managed to send her off to another house-sitting job.
something like that.
Now, we'll stay there.
Oh.
Stay there. We've got out in the other room, and I won't set up the out in the other room. We've got a bit of entertainment, which
Doesn't work.
doesn't work.
Doesn't work because the ball goes straight through the right hand bat.
Yeah, because you've got to push the start button. It's gone past the.
Oh right. Yeah,
Past
that's
the-
what was wrong
yeah,
with
yeah,
it.
yeah.
Against the 15.
Mind
Yeah.
you, the bat jumps around all over the place anyway.
Yeah, 'cause that's a noisy pot, which is I left it that way because it gives you a bit more challenge.
Challenge,
So-
is that what you call it?
So what we've got in the other room, which is a bit of entertainment, because this is actually our end of year barbecue night. We've got a Pong game, which is a video brain game, and it's circa 1970s. Output on channel 0, VHF channel 0, and I suddenly realised, okay,
Couldn't use that in Melbourne.
how yeah, there's a little switch inside which allows you to
Gives
go
you
to
channel 1 generally.
But how do I actually get the output of this? And then I realised that last week I brought in a piece of test equipment that I got from my favourite shop, the Resource Tip Shop, which was a Grundig, so good German engineering, Antenna Mess computer ME90, which came from the Department of Communication Wollongong branch, according to the stamp that's in the manual. And what it is it's an analog.
The manual came from Wollongong.
Analog television antenna analyzer. Basically, you can connect up an antenna in the input socket and basically do a scan of all of the television frequencies, and it gives you the level of those frequencies and also some other information for each of those frequencies, and you can go all the way from VHF from just high band HF just below VHF, but all the way up to UHF, so you can scan all of the television bands. So
plug in channel 0 output Pong game and do a scan, and magically it finds it. And I thought that's a fantastic use for probably a piece of test equipment that we estimate is probably worth somewhere in the vicinity of $10,000 to $20,000 back in the 1980s. It does have a very nice little line printer where you can print out the results.
Oh, there is the image.
On the front. No, this is
the game score. You can print out the game
Well,
score.
like
No.
dot matrix printer.
It's a little dot matrix printer that's a little, the cash register type socket on.
Sitting in the top.
The tape, the ink tape is a bit dry on it, but because I suspect the last thing it printed was probably back in 1987. However, that's a bit of intrigue that we've got going next door, and people have had a bit of a go on it, playing.
Well, that's a nice little Christmas treat to visit to a flashback. I actually had that very game back in the 70s, and
Now,
Who didn't?
can I just say, this is the deluxe version, so this was probably worth a lot of money, a lot more than just the normal Pong game, which is why everyone built the ETI one.
Yeah, I've got the ETI one somewhere.
But this gives you tennis, it gives you hockey, and it gives you squash, and it also has a practice mode.
wow,
And you can change the angle of the ball. It goes from 20 degrees normally to 20 or 40 degrees. The speed and also the bat size. And you can auto serve or you can manually serve. It's got all the bells and whistles.
well, mine must have been the basic one, but I think you could change the speed and the bat size.
Okay.
Yeah.
I love
Yes,
it.
I remember building one of those too.
Maybe I had the twin pots so you could play doubles. So did it have option for doubles?
Well, you had to have 2 players if you can play.
No, doubles.
As in
Which is
4
4
players.
players.
4 players.
Because each controller had 2 pots on it.
And did it actually put one set sort of at volley and one set at the baseline?
Hey, this is 1970
Yeah, okay.
something
Right.
we're talking about.
No.
30, 40, 50 years ago. Oh my God.
I love it.
I noticed in the club room there's a collection of calculators.
There is, from Richard Rogers.
Ah, yes.
In fact, can you go and get them? Because they're very interesting calculators.
Old part.
We'll finish off with Richard Rogers calculators. So yeah, and we've got a large, probably our largest studio audience tonight.
3.
Yeah. Well, we're tripling our normal arrangement. Yeah, I understand these are from Richard Rogers. So what we'll do is the very first one, which is a little bit familiar to me.
I noticed none of the 3 have an equal button on them.
Well, because the HP print calculators have an enter button instead.
Reverse Polish notation. This is a HP 37E. This is a financial calculator. And it still works.
It's not going to air, Justin.
Oh no, it is. It's just we're not looking at it up there.
Oh, right.
So this is HP 37E. It's got a lot of the financial functions already here. Amortization, all sorts of things. So this is a financial calculator.
What are typical financial calculations?
GST.
Well, percentage. No.
Original, that's the rubbish.
It's percentage. Present value. What's PMT stand for, apart from what we think it stands for?
PMG.
PMT.
PMT.
FV, the store and reclaim, which is the memory. Percentage. Percentage T. It's got amortization. What else has it got? It's got the standard
What is
price. Well, that's the equivalent of the enter key. So this is, if you're doing amortization calculation over a number of years, you in effect are pressing the equals key to get the number of, you put in the number of years, you put in the number of the starting percentage, etc., etc., and then the rate that it goes up, and you end up with what the figure is at the end of the period of time. You amortise. Anyway, I'm not a accountant, so I'm a geologist.
Has it got inflation on it?
Well, it probably has the ability to do inflation, calculate inflation. But anyway, so this is, and this is Richard Rogers VK7RO's calculators. So that's the HP37E, and it has, the key thing here is it's got LED display. So this is one of the, it's not LCD, it's LED, which is a stock standard HP. I notice he's lost the cover off the back because he's holding the battery ends with blue tack. Now, this one, which I don't think has, no, it hasn't got any batteries in it, but it's a Novus Mathematician. This also is LED. The little LED, I think you'll find that it's the little LED X, the little alpha LED figures. Cool. In a bit. So this is a standard scientific calculator. So sine, cos, tan, and the inverse. You've got to the power, natural log, 1 over pi, square root, log, etc., etc., and some memory functions. So I've never seen one of these, but it's a Novus Mathematician. So, and I reckon, unless there is a date on here, it runs off 9-volt battery. No, there's no date on here, but I estimate this is probably 70s. I reckon it's about 70s. So this is when scientific calculators were pretty impressive things. And then the other thing that was there is a Chinese calculator, which is an abacus. Now I can't tell you anything about an abacus because I don't know. So could somebody tell me about how you actually count on an abacus? I assume it's units.
Your units,
yep.
5.
Okay.
When you get to the 5, you would then move across your 5th digit.
Okay.
And
then start again.
Count your 5 again, and then you can move it across, and then you into your 10s.
Oh, okay.
That's as much as I know.
Okay. Okay.
Outside of that, couldn't tell you anything.
So to watch somebody use one of these who actually knows how to use them, they're pretty impressive.
They are. Yeah.
Pretty impressive calculators. So an abacus. And it is actually, let's see if we can get that. This is actually a real...
You just push the reset button.
Sorry? Oh, yeah. Sorry, on the abacus, I just put it, you spot on, right? Can we... I'm not sure that we're going to be able to...
Made in China.
But it is actually made in the People's Republic of China. So it's a lotus flower brand abacus. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's interesting. Anyway, so that's
To watch a YouTube clip on how to use an abacus.
and I haven't got one tonight, so what we'll do, okay. We'll, and thank you to Richard Rogers, VK7RO, for bringing those in. Absolutely fascinating, and absolutely fascinating about the HP. I've got a couple of HP calculators in my collection.
Do you gentlemen have any interesting calculators at home? Perhaps we could have a calculator show and tell evening.
Casio were the king of calculators. They had the best calculators.
Yeah, and in fact, my go-to everyday calculator is a Casio.
Yeah. So
Yeah.
for many years I had a Casio calculator that was basically a fold-out flat device. It was like a wallet,
Okay.
and it had every function.
Yeah.
It was a brilliant calculator. Solar powered. It was great.
I for a long while used a Sharp calculator, and the reason I used the Sharp calculator was it was one of the few that did. It actually had the conversion functions for binary, hex, octal, and there was one more.
I see my Casio did all that.
So and that's the reason I use that calculator.
Hex.
Decimal, of course.
Yeah.
No, decimal. So binary, hex, octal, and decimal, and you can convert between any of them.
Yep.
And it was very handy when you were doing assembler programming to make sure you had the right bits
yes,
right.
if you were playing with a Z80 or whatever, yes.
Correct.
Yes.
So, and I've still got that calculator, and I walked into a $2 shop in Adelaide about probably 10 years ago, and there was a copy calculator of the Sharp that I had that was $2. And I think I bought 2 or 3 of them. Because it was like a good copy. Like quite a good copy.
Well, and it worked.
And it worked. And I just sort of went, you got to be kidding. Like, that's my calculator. So anyway, the video tonight that I'll go to is the is Ham Nation number 386, which is the latest Ham Nation. We didn't quite get through all of it last week, so I'll restart it tonight. And it's got an excellent segment on RFI protection. So an RFI, tracing RFI problems and how to solve them. So that's the reason I put it in there. So anyway, we'll get underway with our videos. Thank you for all of our input and our studio audience who is in here, our biggest studio audience I think ever, with all 3 or 4 people. So and also 5. Rex and Alan, who were our presenters tonight. So fantastic. This is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our ATV night 73.